All right, here I have basically three triangles. What I'm going to do is I'm going to talk about two of the triangles. Let's talk about this little one right here. See this little skinny one, ABD? And let's talk about the whole big one. What they're going to ask you to do, they say this. Let's write down what they say. This is on the bottom of 61 if you want to follow along. It's example 8.1. It says in triangle ABC. So here's triangle ABC. That's that whole big triangle. Do you see that? In triangle ABC, it says segment BD is the altitude to the hypotenuse AC. Then it says show the following. And we've already shown that in the picture. I mean, segment BD is the altitude. Altitude means it hits at a right angle to the hypotenuse AC. So we know that's the hypotenuse because that's the right angle. So they're just basically restating what we see in this picture right here. Here's the question, though. It says show the following. I'll just put show. Show that AD to AB equals AB to AC. Okay. What we're going to do first of all, and this is part of your answer. What I want to do is I want to see. Let's take a look at these sides. AD is this little side right here. AB is this one right here. Everybody see that? So if I compare this little one to this one, it should equal what? AB, this one here, the same one we talked about, to AC. So what I'm doing, look at AC. AC is a side of that whole big triangle. AB is a side of that whole big triangle. You follow me on that so far? Look at these two. AD is a side of this little triangle, and AB is a side of this little triangle as well, right? Because AB is shared by both triangles, isn't it? Okay, it's shared by the little one and it's shared by the big one. So if I take a look at what sides I'm talking about AD and AB. I'm talking about AB and AC. So I'm talking about this little triangle here, and I'm talking about the whole big triangle right there. What I want to do is show that those triangles are similar to each other. Now remember, in order to be similar to each other, they have to have two angles in one triangle that are equal to two angles in the other triangle. Let's see if that's true. So look at this little tiny triangle. Now it's not shown in this triangle, but if this is a right angle, what's this angle right here? That's a right angle as well, isn't it? Okay, so this little triangle has a right angle. What about the big triangle? Does the big triangle have a right angle? Yeah, obviously at angle B. Do you see that? Alright, so they both have a right angle. Do they share any other angles in common? What corner? Give me a letter. Give me a point.
C.
C? You sure C? Yeah, they share A, don't they? They don't share C. This little triangle right here doesn't have angle C as part of it, does it? Okay. What angle does the little triangle and the big triangle both have in common? They don't have angle C. They have what? They have angle A. Do you see it? Alright, so they both have angle A, and they both have a right angle. So tell me something about the big triangle, and tell me something about the little triangle. They are what to each other? They're similar to each other. That's right. What I want to do is I want to make sure that I know which points correspond to what. So I'm going to call this, what do you want to call this? ADB? Doesn't matter. They do this in the book, so I'll stick with what they call it in the book. Call it ADB. Now look what you're going from. Now this is not hard. Now similar. Do you know the symbol? It's just a one little squiggle is all it is. That means they're similar. Now when we talk about similar triangles and we talk about congruent triangles, all the vertices have to match up. So the A, look over here. In this triangle right here, which angle does angle A in the little triangle? See, this is the small triangle right here, isn't it? I'll just put small over top of it. So that's the small triangle. I want to compare it to the big triangle, and I want to make sure all the equal angles match up, because in similar triangles, all the angles are equal to each other. Okay? All the sides may not necessarily be the same, but all the angles are equal to each other. So little a or angle A in this little triangle, I should say. Angle A in this little triangle is equal to what in the big triangle? What's that? Now look, what did we say earlier? I put this little arc here. Why did I put this arc here? Because they both share that same angle, right? Angle A is in the little triangle and it's in the big triangle. So what's angle A in the little triangle equal to in the big triangle? Angle A in the big triangle, right? They're both the same thing. So if this starts off A, what's the big triangle going to start off as? A. Do you see that? Because the A and the A are the first ones. What about the D? I went ADB. Well, D is where the right angle hits, isn't it? In the big triangle, here's the big triangle. Where's the vertex where the right angle is in the big triangle? It's B, isn't it? See, here's angle B right here. That's where the right angle hits on the big triangle. So I'm going to put a B right there. Now what about angle B in the little triangle? See, I'm talking about this little tiny one right here. Now remember, all three angles have to equal each other if they're similar triangles, okay? All the corresponding angles have to equal each other. So I've already got angle A, I've got angle B. What is this angle right here in the big triangle? I've already got A equal to A. I've already got this right angle equal to this right angle. So this little tiny one right here, what's the other one left? What's the only one left in the big triangle? Angle C down here, that's right. Okay, so if I put two little arcs here, guess what I can put here? I can put two little arcs because those two angles now are going to be equal to each other. You see it? So if I call this ADB, right here, what am I going to call the big triangle? A, B, what? C. See how the A and the A match up? They're equal to each other. The angle D right here where the right angle is in the little triangle is equal to angle B in the big triangle. You see it? Because they're both right angles. That's why they're in the same spot. What about little angle B in the small triangle? Well, it's the other one. It's the third one, the one that's left over. So which is the third one in the big triangle, the little one that's left over? Angle C is. So angle ADB is, or triangle should say, ADB is similar to triangle ABC. Now that's very important because watch what I want to do. This is what I want to show. And the way that I get this from these triangles. I need to show this. So when you have a problem, and I just look, let's see what problem it is. It's problem number 9 on problem set 8. Okay, it's number 9. You'll have one that looks very similar to this, very close. I should say close, okay, without saying similar. Now watch what we can do. If I compare AD, watch what I did. Look what they do. They say AD to what? AB. What should that be equal over here? Look what I did. I did the first two to the first and the third one. You see it? I went the first to the second and then the first to the third. Guess how I'm going to compare it over here? The same way. So what's it going to be over here? Yeah, the first, right? The first and the second, right? To the what? First and the third. Which one's the first and the third? It would be AC. Okay? Let's do one more comparison. We could do another one. Watch, we went the first to the second, the first to the third. What's another comparison I can make? I could compare the what? Second to the third, right. So I would call this what? DB, and then the second to the third over here would be what? BC. Do you see how we set them all up? This is basically what they want as an answer. This is what they want right here. So the problem will say, show that this is true. Okay, what do you need to do first? You first need to set up your similarity with your triangles. Once you set up your similarity with your triangles, then you can set up your proportions. Show all three proportions. One of those proportions right here, or one pair of those proportions, need to be what you want to show. And that's it right there, isn't it? Isn't that the same thing that they wanted you to show? Yeah. So where did you get it from? You got it from those triangles being similar to each other. Alright, it's important that you write that. If you don't, if this is on a test or a quiz or something, and you don't write the proper similarity with those triangles, then you're not going to get this problem right. Okay, so the important thing is to look at your triangles, set up your similarity, and then you can set up your proportions. Once you set your similarity up, that's really easy. Okay, once you get your triangles similar to each other, the rest of it's really simple. Alright, I know that's a little bit confusing. If we do that a couple more times, you'll start seeing it. But there it is. If you need to look back on it, go to YouTube, look at it. Okay, look at how I explained this whole thing. Alright, let's pause this and we'll do one more type of problem, and that will pretty much be it. All right, here's a situation right here where you have a bunch of parallel lines. In fact, you got 4 parallel lines. This could work with any amount of parallel lines that you have. All right, well, 3 or more. And what's going to happen is we've got a transversal here, and we have a transversal right here. Everybody see that? This is supposed to be a G. Looks kind of weird. All right, so what we've got a transversal cutting parallel lines. What this thing says, I'm not going to go through the whole explanation of it. It's on page 62 and 63 if you want to look. But basically, it's just saying that these, I wonder if they have a nice little theorem or something. It says, we see that the parallel lines cut proportional segments from any 2 intersecting transversals. Proportional segments. All these segments are in proportion. What in the world does that mean? It means this. Watch. If I can compare A to B, watch what I'm going to do. I'm going to go A to B. If these lines are parallel, this only works if these lines are parallel, cut by these transversals. If I can compare A to B, then what do you think? Just off the top of your head, what do you think a comparison is going to be? C to what? Yeah, C to D. And what else? E to F. And G to H. Okay, so we can do it like that. That's one comparison that we can make. Now, we're not going to use all 4 of them, but they're going to give you, I'll do an example here in a second, but they're not going to use all 4 of them, but I just want to show you how you can make these comparisons. You can compare this another way as well. Watch. You watching? I could do this. I could compare A to C. I can compare this segment. Now, when I talk about A, I'm not talking about the angles. I'm talking about the lengths of these segments. Do you see it? So I'm not talking about the angles. I'm just talking about how long these segments are. I can compare A to C. Now, if I compared A to C, how else do you think I'm going to make a comparison? Yeah, come over here and make it B to D. Everybody see that? Or you could go A to E if you wanted to. You could do this all afternoon if you wanted to, or morning. A to E, what do you think you would compare it to over here? B to F. Good. Do you see how that works? What are some other comparisons? E to G, let's go. If I went E to G, what would I do over here? F to H. You see that? It's pretty easy. One way you can't compare it, just be careful about this. You cannot compare diagonally. You can't go like A to H equals B to G. You follow me on that? Just make sure you don't compare them diagonally, either up or down or across. Don't ever compare them diagonally to each other. All right, how in the world is that going to help us? Well, let me do it. Let me draw a quick example right here and show you how we're going to use this to actually solve for stuff. All right, and this will be the kind of stuff that's on the homeworks. All right, here's our example. What we can do is we can make a comparison now. We can compare this to this, this to this, or we can go the other way as well. X plus 1 to 13 or x plus 4 to 19. The only way that you cannot compare them is diagonally. You cannot compare it x plus 1 to 19. You with me on that? Make sure you don't do it that way. You can compare left to right or up and down. You can't do it the other way. All right, so I don't know, a couple ways you could do it. How do you think you want to set this up? Doesn't really make any difference. Let's compare up and down. All right, x plus 1 to 13. So let's do that. So when I say compare them, we're going to write it as a ratio. X plus 1 over 13. Now, if I can compare it the top to the bottom here, what am I going to have to do over here on the right side? Come on, talk to me. Act like you're awake here. X plus 4 to what? To 19, right. So I'll go x plus 4 to 19. And now we can solve for x. So how do we solve for x? Well, we cross multiply. So it's going to be, let's do this over here, give myself some room. So it's going to be 19 times x plus 1 equals, cross multiply here, that would be 13 x plus 4. All right, distribute. 19x plus 19 equals 13x plus, what's that, 52? Subtract 13x from both sides, I get 6x. Subtract 19 from both sides, and what do I get there? 40, 30, what's that? 3? Yep. Okay, divide both sides by 6, and x. Reduce it. What goes into both of those? 3 goes into both of them. 11 times what? 2 times? So it's 11 over 2, and that's your answer right there. 11 over 2. So that's the kind of stuff that you would do with this. All right? That's all there is to that. Let's try one more. Well, yeah, we got one more to do. I don't think we have enough time. We might just save that for tomorrow. All right, well, work on lesson 8 tonight, okay? Get most of it done. There's probably only one or two that you can't do. All right, but work on lesson 8 tonight.